Hello, my name is Nazeer from the Faculty of Civil Engineering Technology, and I will be presenting to you bearing and deflection angles, forward and backward bearings, and determining the bearing of a line. This is the introduction to more complex problems, so we're just going to define a few terms for you. When we look at the term bearing, it is the clockwise rotation from north to the line. The bearing has to be between 0 and 360 degrees. If it is outside of that range, 360 degrees has to be added or subtracted from it. When we look at this red line right here, we could see that the angle in here is from north to that line. That is considered to be the bearing of that red line. And likewise, the blue line, it is the angle from north to that blue line. If we wanted to find the angle between the red and blue line, we would just have to subtract the bearing of the red line from the bearing of the blue line. We will use that in more complex problem, and it will be explained again. Let's go and look at what a deflection angle is now. It is the amount of angular deviation from a straight line to stay on course. Okay, the amount of angular deviation from a straight line to stay on course. Clockwise deflection is considered to be positive. Counterclockwise deflection is considered to be negative. As you could see, we have a closed loop traverse here. What this means is that the starting point of this traverse and the ending point of the traverse is the same point. It's a closed loop traverse. As we travel from A to B, to stay on course, we have to deflect a certain amount, and that is an angle. That's the deflection angle. In this case, we are deflecting clockwise, so it's a positive deflection angle. When we travel from B to C, again, we have to deflect at C clockwise to stay on course. And likewise with D, E, F, we have to deflect clockwise. If you notice, we have gone in a full circle here, which is 360 degrees. So if we were to add up our deflection angles, they should add up to 360, and we will be using this concept as a check in further problem, more complex problem. But that's what a deflection angle is. It's the amount of deviation from a straight line to stay on course. Clockwise rotation, positive. Counterclockwise rotation, which is this direction, would be considered to be a negative deflection angle. The bearing of a line. The bearing of a line is the bearing of the previous line plus or minus the deflection angle depending on the rotation. If we're rotating clockwise, that bearing, the deflection angle will be positive. If we're going counterclockwise, it will be negative. Let's look at finding the bearing of BC. For us to actually find the bearing of BC, we have to be given a bearing, which is given in red here for AB, 40, 10, 50, and we're given a deflection angle also. In some cases, we have to find the deflection angle, but that comes again in further lessons. Because we are deflecting clockwise, this deflection angle is positive. If we were deflecting the other way, it would be negative. To find the bearing of BC, I just have to add the bearing of AB to the deflection angle of 30, 10, 0, 0. The formula down here, new bearing is equal to the previous bearing plus or minus the deflection angle. The plus or minus is depending on your rotation, whether it's clockwise or counterclockwise. As you could see, the previous bearing is 40, 10, 50. The deflection angle is 30, 10, 0, 0. When I add them together, I have the new bearing for BC of 71, 20, 50. So it's fairly easy calculation to do. You just have to add the previous bearing to the deflection angle to get the new bearing. Let's look at a line now. When we look at a line, there are two different types of bearings that could be applied to a line. We have a forward bearing and a backward bearing. The difference between the forward and backward bearings is always going to be 180 degrees. If I want to go from one to the other, I have to either add or subtract 180 degrees. When we look at this, this is usually in surveying called the compass rose. It is in other subjects would refer to the Cartesian system or the rectangular coordinate system. When we look at the line, there's two positions on the line. We have the higher position, the lower position in this case. If I were to take the compass rose and place it on the top of the line, we would see that the bearing of 130 degrees 00 minutes 00 second makes sense because it happens in the right quadrant. We have 0 as north, 90 degrees, 180, 270, and 360. Now, 130 fits right between 90 and 180 degrees, so it makes sense that it is in that quadrant. That is a forward bearing. If we were to take the compass rose to the other end now and place that, we would see that 130 degrees does not make sense in this particular quadrant. This is 270, that is 360, 130 does not fit in between those numbers. Therefore, we have a backward bearing here. To go to the forward bearing, we have to add 180 degrees to 130 degrees. I'm going to add 200 degrees, so that brings me to 330, and I'm going to add minus 20 degrees, which brings me to 310. So the bearing, the forward bearing of this line is 310 degrees. As we could see when we were in this position, the top position, 130 made sense, it was the forward bearing. When we were in this position, 130 did not make sense, it was the back bearing, we had to change it into the forward bearing. To do that, we add 180 degrees to 130 degrees, and we got 310 degrees, which makes sense in this quadrant. As you see, 270 and 360, we have 310 right in between. So that is the correct bearing for these particular lines. That's all I have for this lesson. Hopefully it'll help in your understanding of bearing and deflection angles and how they work. Thank you. Bye-bye.